Alrighty guys, so we're going to continue on with our next lesson in Unit 3. We're going to talk about parallel lines and the triangle angle sum theorem. Okay, so you might be thinking, well, we've been talking about parallel lines and stuff, Mr. T. Why would you just randomly throw in something about a triangle? Well, specifically, the first theorem we're going to talk about is what all three angles in a triangle measure. Now, you all know a triangle is something like this. It's a three-sided figure, A, B, and C. And so if we had time in class, or if we were in class in person, we would prove the theorem is getting ready to come up. Okay? So, I mean, I'll show you in a minute, but the theorem says that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. And how we would do that was we would have just an arbitrary triangle, which means just a regular triangle, or ordinary, does not matter what it is. We would construct a line through one of these points so that it's parallel to one of the sides of the triangle. Okay, and then we would use some alternate interior angles to prove that we've got all three angles added to 180. And I'm not going to go through the whole entire proof here. I'll probably just attach a picture of it somewhere, just so you can see it. You don't have to know exactly how the theorem works. I just think it's cool to see how it works. But anyway, so here's the actual theorem. In mathematical talk, it says the sum of the measures of the angles in a triangle is 180 degrees. So what do I tell myself? All three angles in a triangle add up to 180. All right. And I'll have a separate video link posted to this corny little video I like to show when I teach this topic. It's called Mr. Triangle, and I encourage you to go watch it just because it's corny, and I'm corny, and it's corny. I think you'll find it funny. You'll probably think I'm a dork, but that's okay. All right, so we're going to use this theorem on a couple of examples. All right, the first two start a little easy, and then the last two get a little bit more challenging, but that's okay. So on this first one, we have one angle marked angle 1, and the other two are marked 117 and 33. So we want to find out what this angle 1 is. Well, we're going to straight use the theorem. Measure of angle 1 plus 33 plus 117 equals 180. If you wanted to be super technical, you could do it that way. Then we would do some algebra. We're going to add 33 plus 117 is 150. Then we'll subtract 150. So the measure of angle 1 is going to be 30 degrees. I'm just double checking. Yep, 30. Okay, now, that's the super long and drawn out way to do it. If you wanted to be super technical, what most kids do when you have just the numbers like this is they do this. They know it equals 180, so they start there. And then they subtract the other two measures, and they just type that in their calculator. And honestly, I'm perfectly okay with that. So if you want to be super quick about it, just do what I've got written here, 180 minus 117 minus 33. That'll get you the 30 degrees. Or if you want to be more technical, you could do that equation I wrote earlier. Either way works for me. I don't really care. All right, this next one. We got to find the measures of these Variables. Sorry, I had brain fart there for a second. We got to find out what these variables are. So we have an x and a y here. And if you'll notice, x and y are vertical angles. And then we should remember that, hey, I know something about vertical angles. I know they're congruent. So if I find one of them, I know what the other one is automatically. Now let's be smart about this. The only thing we can find out quickly is what x is, because y is just some other random variable outside the triangle. We don't know what it is yet. But we can use this 70 and the 30 to get the x. So I'm going to use the fast way. I know that 70 plus 30 plus x has to be 180. So I'm going to do 180 minus 70 minus 30. What's that give me? I think it's 80, but let's double check. Yep. So it would say the measure of angle x equals 80 degrees. And now because x and y are vertical, we can go ahead and say the measure of angle y is also 80 degrees. Okay? You might have to do that sometimes. You might be asked to find one angle, and then the other angle you have to find is vertical. So you'd have to do that. Or, as we'll see here in a minute, might have to use a supplementary thing. All right, now I'm going to clean up this right here so I have room to work. Let's look at C. So this time you've got technically there's three triangles here. Okay, there's a triangle. Let me draw them out for you. There's this triangle in green. There's this triangle here in red. And then there's the really big triangle in black. So you're probably freaking out like, I don't know what to do. I'm gonna show you what to do. Okay, so don't freak out. You're probably gonna see triangles like that where you have multiple triangles in one. If it were me, I'm gonna start in a triangle that I know two angle measures. Because I know if I know two of them, I can find that third one really easily. So I noticed that in this small triangle right here where there's 30, 80, and x, I can find that x super quick. Okay? Because I know that 30 plus 80 plus x have to make 180. So 180 subtract 30 subtract 80 is going to equal my x. Well, what is that going to be? So let's find that out. So just type that in. 180 minus 30 minus 80, we get 70. And 70 degrees specifically. All right? Now, because we're going this route, let me go ahead down here and label it. Because we're going this route, I would have to find y next. Because the 40, the y, and the x, they make their own triangle that's going to add to 180. And I can't even find z yet. Well, technically I can, but I'm not doing that way. The way I'm working it, we're going to find the y first and then go to the z. Okay? So this 70 and this y are related because they together make a linear pair. They're supplementary. So I know that 70 plus y is another 180. So just subtract it. Y is 110 degrees. You put boxes around my answers. Yep. I don't know why I double check myself. I know I'm pretty good. All right, so now I know this is 110. And now I can use the 110 and the 40 to find z, because I know those three together make another 180. So I'm going to say 180. I don't want to write it there. Hang on. Let me scoot it over. Up here. 180 minus 110 minus 40. That's what z is going to be. So 180 minus 110 is 70. 70 minus 40 should be 30 degrees. Okay? Now, just for time's sake, I'm not going to show the other multiple routes you could go through this. There are multiple ways you could approach this problem. It just depends on how your brain works. What I wrote here is how my brain works. And I figured most kids' brains work that way, so I just showed that to you all. And by the way, this thought just popped in my head. This kind of question right here, where you have to find 3 different variables, is a good ACT question. They like to ask this. All right? So keep that in mind whenever you get there as juniors. All right, D. Now, my favorite. Now we got to do a little bit of algebra. So we don't know any of the 3 variables or angles, but we know that they all have a variable in them. And so we have to write an equation. We know that 2x plus 4 plus 2x minus 9 plus x is going to equal 180. So let's do that. I'm just going to start with x just because that's first. Or that's small. So plus 2x minus 9. That equals 180 degrees. Okay? We got to combine like terms. 2x and 2x gives me 4x. Another x gives me 5x. And then 4 subtract 9 is minus 5. Now we're going to add 5. $185 divide 5. I don't know what that is. I think it's 61. Nope. I'm totally wrong. It's 37. That's hilarious. Okay. Yep, 37. Okay. So now, if the question just said find x, that's where we would stop. Okay? But you probably figured by now, I'm not letting you off the hook that easily. Okay? You could be asked to go back in and substitute this x into everywhere there's an x and find the specific angle measures. Okay? All right, so I'm leaving a note for myself. We know that x was 37. Okay, now I'm going to erase this work I've got written here in green, and I'm going to show you what you would have to do if you were asked to find the specific angle measures. In other words, what you have to do when you have to substitute x back in. All right, so let me erase all this. Let me get rid of these green dots. There we go. I'm going to do this in blue. So we have to find what x equals, what 2x plus 4 equals, and then what 2x minus 9 equals. Okay? So everywhere there's an x, we're going to put that 37 in. Well, this one's kind of stupid. There's 37. This would be 2 times 37 plus 4. And you would type that into your calculator, or if you're good enough to do it in your head, you could do that. This is going to be 2 times 37 minus 9. And we get 65 degrees. Now, how do we know we're right? How do we know our answer was truly 37? Well, if you wanted to double check yourself, you could take 37, the 78, and the 65 and add them together. And I got 180 again. So that tells me that my answer of 37 was correct. All right. So that's the interior angle sum theorem, which means all three angles inside your triangle equal 180 degrees when they're added up. Okay? Now let's pause here for a moment and talk about classifying triangles. You may have done this earlier in your math career, probably around 8th grade. Okay? I'm not sure. I think that's where you'd learn it is 8th grade, sometime in middle school. But when you classify a triangle, you can classify it two ways. This top row is when you classify it by its angles. So normally you all know what acute is. If a triangle is acute, all the right angles, or excuse me, right angles, Lord. All the angles in the triangle are acute. And remember, acute means they're smaller than 90, so angle measures like 30, 45, 60, 80, that kind of stuff. Excuse me. If a triangle is right, one angle is 90 degrees, and you'll see this little box here, or you could see the number 90. Okay, just one. Only one angle can be right. We'll learn later in Geometry Part B, if you make another angle in a triangle 90, it bumps up to a quadrilateral automatically. That's later. So you got one right angle, you call it a right triangle. If you have one obtuse angle, that would be a big angle. You call it an obtuse triangle. Remember, obtuse angle measures would be stuff bigger than 90 but smaller than 180. So things like 100, 130, 150, 165, that kind of stuff. And then there's a special kind of angle name when all the angles are congruent. We call it an equiangular. That's a fancy word, equiangular triangle. Okay? And then the other way you can talk about classification is by its sides. So in other words, if your side lengths are the same. If all three side lengths are congruent, we call that equilateral. And you'll know that because on your triangle, you'll see these little tick marks. Or they'll give like actual measurements. So they could say all sides are 4 or something. You'll see that either way. If at least two sides are the same, we call that isosceles. So you would see two tick marks, or you would see measurements like both sides of these are 9 and this other one's like 4 or something. I don't really know what it would be, but at least two sides would be the same. Okay, so two or three could count. So technically, your equilateral triangles are also they're technically isosceles also. We just go a step further and say because all three sides are the same, we call it equilateral. But that's just an extra tidbit. And then if no sides are the same, we call it a scaling triangle. Okay? So a question you could see, let's say we have a triangle here. So here's a triangle, and I labeled three of the sides, all three sides. And the question could say, classify this triangle by its angles. Okay, I could just say, tell me what the angle name would be. Well, you'd look at the triangle, and in this, the way I've drawn it, I see this box here. So I automatically know that it's a right triangle. Okay, it doesn't matter what the other two are. We call those right. We call it a right triangle. And then or the question could say, classify it by its sides. So you would look at the three side lengths. Well, they're all different. So we would say this is a scalene triangle. Okay? Or I could say classify by its angles and its sides. In which case your answer would have, you would have to put both. You have to put that it's right and that it's a scalene triangle. That's basically how that works. Okay? Now let's move on. Let's talk about what an exterior angle of a polygon is. Okay? So when I say exterior angle, I'm talking about that it's an angle formed by a side of the polygon and an extension of an adjacent side. So let's say I have a square, and I'll take this side and whoop, stretch it out. So I extended this side right here, and then this side adjacent to it. This right here would be the exterior angle. I hope that makes sense. And then now in a triangle, we have some special names. So angle 1 is the exterior angle. That's the one that's outside. And then these other two right here, we call those the remote interior angles. Okay? Interior kind of makes sense. They're inside the triangle. And exterior means outside. This remote part, I think about it as they're far away. They're far away from that angle 1. Because I think of remote, that makes me think you're far away from like civilization and stuff. So a remote interior angle, they're far away from that exterior angle. They're not close. They're not this one that I just highlighted with the black dot. They're not that one. They're far away. All right. And the next slide is going to talk about a theorem about how angles 1, 2, and 3 are related. So it's called the triangle exterior angle theorem. So it says that the measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. Now that's really mathy talk. You're like, what's that? Whoa, Mr. T, what's that mean? Here's what that means. This exterior angle is equal to these two remote interior angles. You add those two up, it's going to equal this exterior. Okay? So let's just pretend if this one's 100, then these two could be something like, oh Lord, I don't know, 60 and 40. Maybe it just depends. If you add the two interiors up that are far away, they're going to equal this exterior angle out here. Okay? That's really all that means. Now let's use it. So these first four examples are kind of like just basic ones. All right? Find each missing angle measure. So wherever we got a missing angle, we got to find it. And you have to pay attention to what you're given. Okay, so we're going to read the triangle each time. So I'm given a 40 and a 30. Those two are they're both inside my triangle. So these, I'm given my remote interiors. And the theorem says if I add them up together, I should get whatever this exterior angle is right here. So we're going to say the measure of angle 1 is going to be 40 plus 30. Add those two together, 70 degrees. Easy as pie, piece of cake. All right, it's literally that easy. So now over here, we're given one remote interior and we're given the exterior. So from the theorem, we know that 70 plus angle 2 equals 113. So we can subtract 70. So we know that angle 2 is going to be 113 minus 70, which when you do that, subtraction, you get 43 degrees. All right. And again, I was super technical and wrote out this whole equation. 70 plus angle 2 equals 113. I'm just being super technical and doing all that. If you want to do 113, subtract 70 in a calculator, totally fine. Doesn't bother me at all. All right, let's come down here. So again, letter C is like letter B. We were given the exterior and one of the remote interiors. We want angle 2. So I know that angle 2 plus the 13 should give me 128.5. So I'm going to say angle 2 should be 128.5 subtract 13. So if I do that subtraction, I get 115.5 degrees. That easy. All right. Now on D, notice that we want what the measure of the exterior angle is and what the angle adjacent to it is. We want both of them. So you've technically got 2 routes you could go. Okay, and on this one, I am going to show you both routes because both ways are equally valid, and I don't really care which way you do it, as long as you get the answers. So the green way, I'm going to show this first way in green, and I'm just going to use that exterior angle theorem we just talked about. We were given 45 and 47. Those are both inside my triangle. Those are my remote interior angles, so I know that when I add these two up, they should give me this angle 3 on the outside. So remember, I'm using the exterior angle theorem. Angle 3, which is my exterior angle, is supposed to equal 45 plus 47. Let's see if I can do this in my head. 40 plus 40 is 80. 5 plus 7 is 12, so 80 plus 12, that's going to give me 92 degrees. Okay, so this one out here is 92. Now I'm going to look back. I'm going to erase that because that looks bad. This looks like 92. So I know that this 92 and this 4 are a linear pair, which means 92 plus angle 4 should give me 180. So I'm going to say angle 4 is 180 minus 92, which that should give me 88. Okay? So the green way is just using the exterior angle theorem. Okay? Now, the blue way, let's just say I don't like this. On this problem, you could say, I don't really care for the exterior angle thing. I want to use the angle sum theorem we learned about earlier, which in this case would say that 45 plus 47 plus angle 4 would add up to 180 degrees. So I could say angle 4 is equal to 180 subtract 45 subtract 47. When you do that math, you're going to get 88 degrees again. And now we have to go back to a linear pair situation that angle 4 and angle 3 add up to 180. So we could say angle 3 is going to be 180 subtract 88, and that should give you 92 degrees. Okay? Again, on letter D, you have options. All right, let me erase what I've done here so you can see. If you're asked to find an exterior angle and the angle adjacent to it, you have options. Okay, and I don't care which option you do as long as you get the correct answers. Okay, and then on the rest of them that we did, A, B, and C, you had to use the exterior angle theorem. That's all you had to use. All right, one more example. So we're going to find the value of the variable y, and then we're going to find the measure of each indicated angle. So when we get done and find y, I want to know what angle A is, what angle B is, and then ACB. So we'll get there in just a second. All right, let's do blue, my favorite color. So we were given angle B is 4y plus 8, and angle A is 5y plus 3, and we have us an exterior angle of 146. So just straight using the theorem, I know that 5y plus 3 plus 4y plus 8 is supposed to equal my exterior angle of 146. Combine like terms, 5y and 4y gives me 9y. 3 plus 8 gives me 11. I'm going to subtract 11. 9y equals 135. Divide 135 by 9. I don't know what that is. Oops. 15. So I know that y is 15. Now I have to go back and use it. So angle A was the 5y plus 3. So I'm going to take my y, which was 15, substitute it in. What's 5 times 15 plus 3? 5 times 15 plus 3 gives me 78. So this angle is 78 degrees. Angle B was 4y plus 8. So 4 times 15 plus 8, that should be 68. Yep, 68. And if you'll notice, what's 78 plus 68? 146, which was my exterior angle, so I know that these answers are correct. Now, last thing I want you to find was the measure of angle ACB. So let's go back to our triangle and follow those letters. ACB. I want this angle right here. How do I find that, Mr. T? Well, again, you got two options. The first option I'm going to do in blue. I know from earlier that we learned about that this exterior of 146 and this inside, they together will make a linear pair. They're going to be 180 degrees together. So I can say that the measure of angle ACB plus 146 equals 180. Now we subtract the 146. And so the measure of angle ACB is going to be whatever that subtraction result is, 34. So I get 34 degrees. Okay, that's what I would do just to save myself time because I think it's a little faster. But you could do what I'm about to do in red, and it's equally valid. You already know that angle A is now 78 and angle B is now 68. Let me erase what I've done here in blue right here. So you could use the fact that 78 plus 68 plus the measure of angle ACB equals 180. So you could say the measure of angle ACB equals the 180, subtract 78, subtract 68, those you just found. And that should give you 34 degrees again. All right. Either way is equally valid. I don't care which way you do it, just as long as you find it. And a hint for when you're doing that, when you have to find this like this an angle ACB, I would stick to one way and just keep it that way. If you are more comfortable on this last part to use this linear pair relationship I've got here in blue, stick with that. That's totally fine. If you're more comfortable with what I've written in red and you like that better, that's fine. Stick with it. I don't care. Just pick one of these ways and stick with it all throughout your problems. Okay? Now, I didn't attach it, but I think your homework is a Google form on all this stuff. So your homework is just answer all those Google form questions. You only have one chance to take it, so take your time and make sure you know what you're doing. And if you need help at any point during that homework, please contact me and ask me for help. I'm more than happy to help y'all.